So for today's lesson, we're going to look at parent and piecewise graphs. First thing we're going to start off with is the 6 most common parent functions. So if you look, the first graph is just a constant. If I would give you a problem, this one would be like y equals 4. So that's your most common. You should have learned about those in Algebra 1. The second one here is linear f of x equals x. Remember, f of x is the same thing as y, so I could have written y equals x. The next one here is absolute value. We've done some problems with absolute value, but we've never graphed them. So here's what your parent function for your absolute value would look like. Just looks like a V that touches the center 0, 0. In the bottom left is a quadratic x squared. We've graphed lots of those in this term. So x squared just looks like a parabola. And then 2, you may or may not have seen before, the cubic and the square root functions. So cubic kind of looks like a zigzag. Square root starts here and actually continues on in this direction only. So this is like a starting point continuing on. All the rest of these continue on. I guess I should add arrows though. But all of these graphs continue. So these are just our parent functions. So the first thing we're actually going to talk about today are shifts or translations. So a vertical translation or a vertical shift is made by adding or subtracting a number to the function. So if you look at these 2 examples here, there's a positive 3 being added at the end and a negative 5 being added at the end. It's very important that they're added, the numbers are being added at the end. So all the way out at the end of the equation. So if I put a plus 3 out at the end, we're shifting the parent function up. So in this first example, that plus 3 shifts the parent function up 3 units. The second one, x squared minus 5, would take that original parabola for the x squared and move it down 5 units. A translation up is also called a vertical shift up. Down is a vertical shift down. So that's your translations, vertical up or down. Horizontal translations can be made to a function by adding or subtracting a number to the variable. So notice in these 2 examples, the 2 has been put in parentheses before the square. So it's been shoved in there with the variable. It's not hanging out at the end by itself. So this is in with the variable, same way with the cube root of x plus 4. These do opposites of what you think they should do. So for this one, since it's in with the variable, x minus 2 actually shifts 2 to the right. So it's kind of similar to that vertex form we talked about earlier in the term. So it's in with the variable, it's doing the opposite. And then the plus 4 shifts left, again, 4 units to the left. Horizontal shifts left and right. All right, so we're going to do a little bit of practice identifying the transformations and identifying the parent function. So the parent function is just take whatever the original is before we started adding and subtracting numbers. So for the first one, we have g of x equals x squared minus 6. Your parent function would just be g of x equals x squared. In this case, your parent function is a quadratic. Then we have to decide if that minus 6 is moving us up, down, left, or right. First thing I want you to decide, is it stuck in with the variable or is it hanging out at the end? It's hanging out at the end. Since it's hanging out on the end, it's either moving you up or down. Do you think a negative 6 out at the end is going to move you up or down? Down. So we're moving down 6. That's the only transformation that's happening to that problem. For question number 2, our parent function, f of x equals, what do you think the parent function is? the absolute value of x. So take the numbers out that have been added in this case, the -1. Then we have to decide, is that -1 hanging out at the end, or is it in with the variable? It's in with the variable. When a number is in with the variable, it does the opposite of what you think. So if I'm doing -1, am I moving left or am I moving right? Right one. So that -1, since it's inside the absolute value bars with the x, it's going to shift the parent function to the right one. For number 3, our parent function, h of x equals the square root of x. That is our parent function. Then we need to determine the transformations that are being made. So that +4, is it hanging out at the end or is it stuck inside with the x? At the end, so it's either going to move you up or down. Which is it? Up 4. Questions on these 3 before we do some more? So since that 4 is not underneath her square root, it's moving you up 4. If it would be inside, like if this square root had been extended, then it would be inside with the x. But since it's not underneath it, it's on the outside.
So if it's with the variables, it's right or left, it's not as up or down.
Yep. We're going to practice some more. Making things harder. So now notice I've added 2 transformations in. I know there are 2 transformations because there's a +1 here and there's a +3 here. So if I take that +1 and the +3 out, that's going to give me my parent function, in this case g of x equals x squared. So another quadratic. Now we have 2 shifts that we need to identify. Doesn't matter which one you do first. One of them is going to move you up or down, the other one's going to move you left or right. So the one that's inside our parentheses is going to move left or right. Oh, I shouldn't draw so many arrows. Left or right. This one's going to move you up or down. So remember, the number that's inside your parentheses does the opposite of the sign. So +1 is actually going to move you to the left one. The +3 is going to do exactly what you think it should do. If it's positive, it's going to move you up. In this case, 3. So the transformations, left 1, up 3. Take a minute and see if you can do question number 6. It again has 2 transformations. So identify your parent function, take the 5 and the 2 out, and you're left with your parent function. And then tell me what that 5 and 2 does. So for our parent function, you should have that the parent function f of x equals the absolute value of x. For your 2 transformations, this one on the inside is either going to move you left or right. This one's going to move you up or down. Keep in mind the one on the inside goes opposite. So instead of going right 5, it's actually moving left 5. And then the one hanging out at the end, the -2, does exactly what you think it should do and moves you down 2. Question number 7, our parent function, h of x equals the square root of x. And again, we have two numbers. One of them's inside with the x underneath that absolute value. That's the one moving you left or right. The one hanging out at the end is going to move you up or down. What do we think is happening? Left 2, down 5. Perfect. Questions on this page? We're going to change it up a little bit. So for these 5 questions, we are going to be given the parent function and then told what shifts need to be made. So for question 10, we are going to start with an absolute value. So here's my absolute value. And then I need to make 2 shifts. I need a vertical shift down 5. Since it's moving down, I know it's going to be a -5. And then a horizontal shift to the right 3. Remember, horizontal is the one that goes opposite. So somewhere in my problem, I need to have a -3 to move me to the right 3.
We put y, or do we have to do?
You can put y. Or you put f of x, h of x, g of x, whatever you want. So y equals, in my absolute value, which one of those 2 numbers is going to go inside? The -3, the one that goes opposite of what you were given. So right 3 means I'm going to have a -3 in with my absolute value bar.
Why is that? Why is it not in, never mind, because that's what determines right and left.
Yep.
So we do left and right first.
So the left or right's always going to get put in with the variable. The up or down's the number that hangs out at the end. So the -5 just hangs out at the end. For question 11, we're going to start with a linear function. Y equals x is our linear function. And then we want to move it up 5. If I'm moving up, am I going to put a +5 or a -5? +5. In this case, I don't really have any options but to put it out at the end. So if I want to move that up 5, I'm going to take the parent function. I'm going to put the +5 all the way out at the end. So y equals x plus 5. Question 12, we want a square root function. So we're going to start with y equals the square root of x. And then I want to move down to left 7. So if I want to go down 2, is that a +2 or a -2? -2. Remember, up or down is the number that hangs out at the end. It takes the sign that you would think. If I'm moving down 2, it's a -2. The horizontal shift is the one that goes in with the variable and it goes the opposite sign. So if I'm going left 7, I want a +7. So when I write my equation, which number goes inside the square root? The +7, perfect. Your left or right always goes inside, and then the up or down hangs out at the end. So -2 does not go underneath that square root, it just hangs out at the end of the equation. Question 13, this time we want a quadratic. A quadratic is just y equals x squared. And in this case, we want a horizontal shift to the left 8. So if I'm going left 8, what am I going to write in my problem? +8 or -8? +8. Oops. Will it go in with the variable or out at the end? In with the variable. So if I'm going to write that in with the variable, I'm going to have to use parentheses. X plus 8 in parentheses, then I can write my squared out at the end. Question 14, we want a quadratic. A quadratic is, again, y equals x squared. And then they're telling us they want a vertex at -5, -2. What that really means is you're going to move left 5 and down 2. So I want to write an equation that moves left 5, down 2. Take a moment and see if you can write that quadratic for us. So for this one, if I'm moving left 5, I want to put plus 5 in my parentheses before it gets squared. So in with my variable, opposite sign. So left 5 means plus 5 gets written in with the variable. And then the -2 tells us we're going down 2, so we want -2 hanging out at the end of our equation. Questions on these? So for example, what this actually looks like, so here's an example, y equals the absolute value of x plus 2. What kind of shift is that plus 2 going to do? Up, down, left, or right? So decide, is it in with the variable or is it hanging out at the end? If it's hanging out, it's going to move you up or down. So I'm going to move up 2. What that means is I'm going to take this original parent function, given to me, and I'm going to move every single point up 2. I'm going to take this point right here at 0, 0, and I'm going to move it up 2 units, and I'm going to put it right there. So every single point on this graph, I would only pick like perfect points, so like right here's crossing exactly, actually all these are. And I'm just going to take them and pick them, move them up 2. So this point goes up 2, and now it's going to sit right there. I'm going to pick the next point up. I'm going to move it up 2. To get this, maybe. So every single point is being picked up and moved up 2. This last point on the left and the right won't fit on your graph, and that's okay. And then I just want to connect them. So here in burgundy, up top is the new function. It should look exactly the same as the original. It's just been picked up and moved up 2. So I shouldn't start with an absolute value and end up with a quadratic or anything crazy like that. So we just picked this red line up, the whole thing, moved it up 2 units. That's all we're doing. We're just moving it up 2. Questions on that? There is a question on your test that I'm going to give you a parent function. You're going to have to do the shifts. So here we did a plus 2 at the end, moved it up 2. Questions or concerns? You just take the original points, move them according to the shifts that you were given. Next thing we're going to talk about are piecewise functions. So everything we've looked at until now has been represented by one single equation. But in real life, functions aren't represented by just one equation. A lot of times they're represented by a combination depending on the domain, the x values. These are what we call piecewise functions. They kind of look intimidating when you see them, but I promise they're not as bad. So a piecewise function is a function that is a combination of one or more functions. Normally for this class, we just do 2 or 3, not a bunch of them. But think about movie tickets. Depending on your age, you get charged a different price for the movie. So if I take my 3-year-old to the movies, she's going to get charged a different price than I am. That's how this would come into play. So the function for movie ticket prices would assign a different value, a ticket price, for each domain interval. So for each age group, you could have a 1-year-old that gets in for free, a 2-year-old's $5, for me to get in is 10. So there would be 3 different values or ticket prices for each age group or your domain. So this is an example of what a piecewise function is. So f of x, you're used to, same thing as y. And then here we're given an equation, 2x minus 1. We're only going to use that equation if the x value we're given is less than 1 or equal to 1. The other one we're going to use 3x plus 1 if we're given an x value that's greater than 1. So if I ask you to find x, make sure this is long. So if I ask you to find x equals 5, you have to decide which one of these constraints does 5 fall under. Is it less than or equal to 1 or is it greater than 1? Greater than 1, so you would use this equation here, down at the bottom. So since x is greater than 1, we would use this equation here. We're going to practice that on next slide. So here we go. We're going to evaluate f of x when x equals 0, x equals 2, and x equals 4. Keep in mind, if I give you this, you can only take 0 and plug it into one of these. You can't plug it into multiple. So you have to decide, according to this or this, do I have a value that's less than 2 or greater than or equal to 2? Is 0 greater than 2 or less than 2? Less than 2. So since 0 is less than 2, we're going to evaluate it at x plus 2. Which just means x plus 2, so f of 0 equals 0 plus 2. Well, 0 plus 2 is just 2. So the function at 0 equals 2, we plug it into that top one because, x was less than 2. So there's the first answer. Then we're going to check the function at x equals 2. So we're going to find f of 2. Take the function and evaluate it at 2. You have to decide, is 2 less than 2 or is 2 greater than or equal to 2? So which one are you plugging in, the top or the bottom? The bottom, because it has the equal to 2. So since it's equal to 2, we're going to use the bottom one. So 2 times 2 plus 1. We're using this bottom part here, the 2x plus 1. Take the x out, replace it with 2. Sure does. So 2 times 2 is 4, plus 1 is 5. So you're never going to do anything with this right part of your piecewise. This is just to tell you which equation or which part you're going to use on the left. And again, you're only allowed to use one at a time. So if I evaluate 2, I can't plug it into the top and the bottom. I can only plug it into one that meets the constraint. So if x is greater than or equal to 2, that's the one we use.
So like, the number is always greater than 2.
So any number that's greater than or equal to 2, we're going to use the 2x plus 1. For any number that's less than 2, we're going to take x plus 2. So I could change these 3 numbers that I gave you at the top to be anything I wanted, really. And you would have to decide, is it less than 2 or is it greater than or equal to 2? And then you're just plugging it in. So last one, x equals 4. Take a minute and see if you can do it, if you haven't already. So first thing you have to decide, which one of these are you plugging into, the top or the bottom? So is 4 less than 2 or is 4 greater than or equal to 2? Yep. So since 4 is greater than or equal to 2, we're going to plug into the bottom. The bottom's 2x plus 1. So I'm going to take 2 times 4 plus 1. Questions on these three? Okay. Whoops. All right, your turn. I want you to figure out these four values. So f of -2, f of 0, f of 5, and f of 1. So for all four of them, you have to decide which constraint you're going to fall under. Remember, you are deciding which one to use based on these two things here. So any number less than 0, you're going to use the top one. Any number greater than or equal to 0, you're going to use the bottom. So for the first one, f of -2 falls under x is less than 0. So I'm going to take -2 times 2 plus 1, which gives me an answer of -3. If I plug in f of 5, 5 is greater than or equal to 0, so I'm going to the bottom equation. So 2 times 5 plus 2, which is 12. The third one, f of 0, this one's kind of the tricky one because you have zeros in both of them. You have to decide, is 0 less than 0 or is 0 greater than or equal to 0? Since the bottom one has the equal to 0, you're going to use it. So 2 times 0 plus 2. Well, 2 times 0 is 0, plus 2 is 2. And then the last one, f of 1. 1 is greater than or equal to 0, so we're going to use the bottom equation, 2 times x plus 2. So 2 times 1 is 2, plus 2 is 4. How are we feeling on these? Okay? All right. Let's move to graphing. So if I ask you to graph this, a lot of students would just panic. Don't panic. So for this piecewise, we're going to use 1/2 x plus 3/2. Don't mind the fractions, it's not that terrible. For any x value less than 1. So for all of our x's that are less than 1, we're going to use the top 1/2 x plus 3/2. So any number that's smaller than 1, we're going to use the top equation, 1/2 x plus 3/2 to graph. It's just a t-chart, x's and y's, plugging things in. The bottom one, -x plus 3 for any x value that's greater than or equal to 1. Oh, I lost my graph. Weird. Skip to the bottom of your page. It matches this, right? Yes, no, maybe?
No.
No?
No.
Oh, maybe mine's wrong. Do you have this page next?
Yeah.
Oh, okay. So keep in mind that this can happen. So here we're using these two equations for greater than 2, less than 2. So they've just taken any x value greater than 2, plugged it in here to get these points along this line. When this happens, so it can't equal 2 and go all the way up to really close to 2. So I could take any value that's greater than 2. I could take 2.01 and plug it in to get this point right here. This is called a point of discontinuity. So our two pieces don't necessarily have to touch each other. This one's an open circle because it's not equal to 2. It gets really close. That's what the open circle means. I can get indefinitely close to it. And then for the bottom one, it's a closed circle here because it can equal 2. So they took 2, they plugged it in, and got -1, and that's how they got this point here. They just took other points, plugged them in to get the rest of them, which we're going to practice on the next page, maybe. Apparently mine's different than yours. Do you have a graph on the next one that looks like this?
Yeah.
Do you have the same equations as I do? Okay. All right, so we're going to carefully graph the following. So for any x value that's greater than or equal to 0, we're going to use 2x plus 3. What that means is we're just going to make an xy table. So when I make my xy table, I'm only allowed to plug in x values that are greater than or equal to 0. So I'm going to start at 0 because it can equal 0. And then I'm just going to plug in 0, 1, and 2. All three numbers are greater than 0. You could plug in any decimal or fraction you wanted as long as it was greater than 0. Would not recommend it, but that's what I would do. So I would use 0, 1, and 2. Again, any number that's greater than 0 is going to work. Then I'm just going to plug these three numbers individually into this equation. So for the first one, if I take 2 times 0 plus 3, you get 3. Again, that was because 2 times 0 plus 3 equals 3. Then we're going to repeat. We're going to use 1. So 2 times 1 plus 3 equals 5. So 1, 5. Then I got to plug in the 2. If I plug in the 2, I'm going to have 2 times 2 plus 3. Two times 2 gives me 4. 4 plus 3 gives me 7. What is it? It's not here. You can see her.
Oh, you gave me 2.
So then I'm going to graph this piece of information. So I'm going to graph these 3 points. I'm going to graph 0, 3. 0, 3, start at the origin, go up 3. There's my first point. My second point is going to be the ordered pair 1, 5, go right 1, up 5. My third point is 2, 7, start at the origin, go right 2, up 7. And then remember, I can plug in any x value that's greater than 2. So these numbers, I could plug in 3, I could plug in 4, I could plug in 5, so on and so forth. So when I draw my line, I'm going to put an arrow on this end over here. I'm not putting an arrow at the starting point of 0, 3. So only the arrow that goes to the right continues because all the values to the right are greater than or equal to 0. Are we okay so far? So we're halfway done. Now we need to forget about this top part. We've already used it. Now we're going to use this bottom part. So any x value less than 0, I'm going to use x plus 4. So I'm going to make another xy table. And I'm going to pick values that are less than 0. Yep. Nope, remember they don't have to connect it to each other. So if I plug in -1, that means I would take -1 plus 4, which is 3. That's going to give me 3 new ordered pairs. So first one I have is -1, 3. -1, 3 happens to be right here. -2, 2 right here. And -3, 1 right there. Keep in mind, I can use any value that's less than 0. That means I can use any number that gets really, 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 really close to 0, like -0.1. So this actually continues up until wherever it meets 0. It's going to continue up and hit right here if you use your little ruler. You have to use an open circle there because the 0 is not included. So put an open circle at 0, 4. You can also get that point if you plug in 0. You're going to get 4, but it's got to be an open circle. And then we're just going to use our ruler and connect them. Which way will my arrow go in this case?
Down.
Down. It's going to continue down this way to the left forever and ever and ever. So here at 0, we have that point of discontinuity. They're not meeting in the middle. They're starting at 2 different points or ending, however you will look at it. So that would be my final graph. Kind of looks funny because you're not used to it. You do have one of these on your file. Just one. And I think it's multiple choice. 2 weeks from tomorrow? Yes, 2 weeks from tomorrow. Questions on this one? All right.
Wait, why is it an open circle?
Because right here, we're using any value that's less than 0, so we can get really, 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 really close to 0, but we can't actually touch that point. So that's why it's an open circle. You only fill in the circle if it equals 0, like this top one equals 0. So if it's less than or greater than, you're going to use an open circle when it gets to that point. Good question. Let's try another one. So for this one, we're going to use any x value that's less than or equal to 1 for this top piece. So we're just looking at this top piece. We're going to make an XY table. We're going to take any number that's less than or equal to 1 and plug it in. I would start at 1, 0, -1. You could keep going. You could plug in more numbers. The more numbers you plug in, the more accurate your graph's going to be. So any number that's less than or equal to 1 will work for this top part, -3x minus 1. So I'm going to take -3 times the x value we were given or we're using minus 1. So we're plugging into that top piece of our graph. Then I'm just going to simplify. -3 times 1 is -3, minus 1 is -4. So my first order pair, I could graph 1, -4. Then I'm going to plug in 0, -3 times 0, minus 1. Well, -3 times 0 is 0, minus 1 is minus 1. For the last one, we're going to take -3 times -1 minus 1. -3 times -1 is 3, minus 1 is 2. So then I'm going to graph these. Keep in mind, when I graph these, since x can equal 1, Am I going to use an open or a closed circle when I do that first point? Since it can equal, anytime it can equal, we use a closed circle. So since this first part, negative 3x minus 1, can equal 1, this first point, 1, negative 4, gets a closed circle.
You said if it equals it?
Yes. If it equals it, it's closed. If it doesn't have that little equal underneath it, it's got to be an open circle. So 1, negative 4, our first point, since it can equal 1, we filled that circle in. Just looks like a point on our graph. Then we're going to go to 0, negative 1, right here. And then negative 1, 2, up here. Which way will my arrow go?
Down.
So think, if I'm using x values that are less than 1, less than points to the left, so you're going to draw your line from this point all the way to the left. So your arrow goes to the left because x is less than or equal to that. So any x value that's to the left of 1, we can plug into that top. So our arrow actually goes to the left. For the second part, we're using the second piece. So we're going to use this here. For any x value that's greater than 1, we're going to just have negative 5. So any number I pick that's greater than 1, so 2, 3, 4, is just going to have a value, of negative 5. You don't even really get to plug them in. You're just getting points to plot. So 2, negative 5, 3, negative 5, 4, negative 5, any number I can pick. As long as it's greater than 1, so any of these numbers here are going to work. But remember, I can get really, 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 really close to 1. I just can't touch it because there's not an equal sign underneath this. So I'm actually going to draw myself an open circle here. It's open here because there's no equal underneath the 1 for that second piece. And then which way will my arrow go for this one? To the left or to the right? For all x is greater than 1. Greater goes to the right. So my arrow goes to the right. You can kind of think of that if you made this symbol right here, an arrow, think of this pointing to the right. Think of this one pointing to the left. That's where your arrow is going to go. If it doesn't equal whatever this number is.
That's where this shift up, shift down, right, left comes in, right? Like if it's, no?
Two different things. Questions on this one? So a lot of plug and chug. So if you look at the next page, you have some graphs to work on and some points to find.